Okay, let's look at this DocSci exercise 18 question 1. It says to you, the following graph is a velocity time graph for an object moving in a straight line. The object initially moves north. Calculate the distance covered and the displacement. Okay, so the first thing to look at is that this is a velocity time graph. So for a velocity time graph, remind yourself that the area under the graph, okay, the area under the graph gives you the displacement or the distance, because displacement is the vector and distance is the scalar. And then the second thing you can get from the graph is the gradient is going to give you the acceleration. Now this question doesn't ask about the acceleration, but if you look at this graph you can see that this is a straight line, and this is a straight line, and this is a straight line. So if these three are straight lines, it means that this object is actually traveling at a constant velocity. You can see it's a flat line, so it's a constant velocity, and the acceleration is then going to be 0 meters per second per second. That's not asked, but it's of interest. So now it says to you, calculate the distance covered. So the distance covered is given by the area under the graph. So you can see here there's this area under the graph, okay, this shape here, which I've drawn very messily. Now this section here from 3 to 5 seconds, there's no area because the car had a 0 velocity. So if you've got a 0 velocity, you actually aren't covering any distance because you're actually not moving. So now this other section here is the second section where there is a distance being covered. So our job now is to find these two areas. So the area of this section, this shape is a rectangle, so the area is going to be length times breadth. So you read the values off the graph. This is from 0 to 3, this is from 0 to 3, so it will be 3 times 3, so this is 9 meters. If you look at the second section, it's from 5 till 10, so this value is 5, and this value is from 0 to negative 4. So, but because the first question asks for the distance, we can just look at this as a positive 4, and we can say the area here, because it's a rectangle, is length times breadth, which is 5 times 4, which is 20 meters. So for the distance covered, it is a scalar. We don't care which direction you're going in. So the distance covered is a total of 9 plus 20, so it is 29 meters. Now for the second part, we need to take into consideration the displacement is a vector. So this value down here of 20 meters in terms of displacement is actually going to be a negative 20, and this one up top here is a positive 9. So the displacement is going to be 9 minus 20, because we're adding them together, but a plus and a minus make a minus, so we end up with negative 11 meters. So we can't leave our answer as negative 11 meters. We need to give it a direction because it is a vector. So we are going to say the displacement is 11 meters, and if you check in the question, the object initially moves north. So if we have a negative value over here, it means this is south. So our displacement final answer will be 11 meters south. And that is the end of the question.